Welcome to our 2-minute exploration of nuclear magnetic resonance, or NMR spectroscopy. Today, we'll delve into some of the key aspects and important points of this fascinating technique used widely in the field of chemistry for the structure elucidation of molecules. Stay tuned as we unravel the complexities of NMR spectroscopy. Let's start by asking, what is the principle behind NMR spectroscopy? Is it A, absorption of UV light, B, absorption of infrared light, C, absorption of radio frequency radiation by nuclei in a magnetic field, or D, absorption of X-rays? The correct answer is C, absorption of radio frequency radiation by nuclei in a magnetic field. This fundamental concept is what allows scientists to analyze the structure and dynamics of molecules. Moving on, in NMR spectroscopy, what role does TMS or tetramethylsilane serve as? Is it A, solvent, B, internal standard, C, external standard, or D, reagent? The answer is B, internal standard. TMS is crucial for calibrating chemical shifts in NMR spectroscopy, making it an indispensable part of this analytical technique. Which factor does not influence the chemical shift in NMR spectroscopy? Is it A, electronegativity of neighboring atoms, B, magnetic field strength, C, temperature, or D, molecular weight of the sample? The correct answer is D, molecular weight of the sample. What is the splitting pattern of a proton signal with two neighboring protons in NMR? Is it A, singlet, B, doublet, C, triplet, or D, quartet? Well, the answer is C, triplet.